Alright, today we will be talking about 6.2. Okay, 6.2 we will finally start to define trigonometric functions for real numbers. Okay, so last time we introduced the unit circle. Now we say we want to redefine everything about sine, cosine, all the 6 trig values using the unit circle. So first, trigonometric functions. This is nothing but the same thing as before, except we standardize everything. So before, we do have this. You have a theta, then you find a point on this theta. You find r, y, x. You define everything in the old way. Sine, let's call it theta. Okay. So you were trying to define the trigonometric value for angles. Y over r and the tangent theta equals y over x, and you have the corresponding flipped secant, cosecant, and cotangent. All right. Now what we do is we do the same thing, but this time we do 2 different setups. First one, you don't pick any point. Once you have an angle, what you do is you pick the point that is on the unit circle. Because you did that, you use the same formula as before, except for your r equals 1. Okay. Second, instead of thinking about this angle theta here, what you think about will be actually the arc length here, which is called, we can call it t, okay, which stands for the distance from the axis to the current terminal point. So this is t. In this way, we redefine the 6 trigonometric values. We have sine t, which is basically corresponding to theta. Okay, but not theta. We have sine t equals y over r, but r equals 1, therefore sine t equals y. Cosine t equals x. And tangent t, of course, is still going to be sine over cosine, which is y over x. Cosecant t is 1 over y. Secant t, flip the cosine. And finally, cotangent t is going to be x over y. So that's the new definition of trigonometric values for real number, not for angle, it's for t, and also on unit circle. To make it more careful, what we have here is if we draw a unit circle and we have a t, then this will be cosine if you do a right triangle. And this will be sine t, which is your x and y value. Okay, so together, it's very easy to see then the point P is going to be given by xy, which is nothing but P cosine t and sine t. So if you know the cosine and sine, you will know where the point is. Meanwhile, if you know the sine and cosine, the point, you will know what the cosine and sine is. Okay. All right. With that in mind, we can define something. Number 1, domain. Number 2, range. How do I do this? Let's do domain, range. Okay. Let's talk about sine x. What can your sine x be? Well, sine x is your y value, right? For any point on this circle, you will have a y value. Therefore, you can put again any number for your t. You will always have a y value. And that y value cannot be as far, the highest y value is here, the lowest y value is here, because you have to stay in the unit circle. So the range is going to be between -1 and 1. Cosine x, you can plug in any number, you have an x value. And again, it's between -1 and 1 from left and right because you need to stay in the unit circle. For tangent x, okay, what do you have? You have y over x. Is it all? I should put t here to stay away from confusion. You have y over x. So you should stay away from where the function has a x equals 0. So if you think about a unit circle, where will the x value for the point be 0? It should be here and here, which corresponding to pi over 2 and the 3 pi over 2 plus a 2 and pi, because every time you add another integer of 2 pi, you end at the same thing. And then you can merge these two into t does not equals pi over 2 plus n pi. That is, you start from pi over 2, you do another pi, you do another pi, you will include both points. Other than this, these ones, your tangent t is defined. The range, of course, is -infinity to infinity. It can be anything. It can be as big as you want because you can take the y, an angle to be here, which you have a very, very big y, very, very small x. Okay. So this one can be 1,000,000, 10 million, and eventually can reach to infinity. That's where you have something divided by 0, and that's why it's undefined. With that in mind, you can do the same thing for the other three. Cotangent t is x over y. Therefore, that is where y cannot be 0. From here, you can see it's just 0 plus pi, so t does not equal to n pi. Okay, range, same thing. Okay. Second, cosecant. Okay, this is 1 over x, this is 1 over y. Therefore, this should be corresponding to cosine does not equal to 0, so t does not equal to pi over 2 plus n pi, and t does not equal to pi over 2, 0 plus n pi. You can verify by yourself. So there are certain values you cannot plug in. If you plug in, you got trouble. Okay, the range, it's 1 over cosine, and you know cosine is always less than 1. Therefore, this one is always bigger than 1. And therefore, this one can be less than -1 if you have negative values. Same things for this. Okay, that's the definition of all the 6 trigonometric functions, this time defined using real number instead of the angle theta. Okay, now we do the same thing as we did before. We will just go over it really quickly. Everything is the same. You just need to rethink it, not from the angle, not from a right triangle. You think it from a unit circle. Okay, the first one is evaluating trig values. And it's still the traditional steps. First one, find the reference number. Before it's the reference angle, this time it's the reference number, but they're the same thing. Second, figure out the value, which only works for anything between 0 and 90 degrees. Okay, but this time we don't think about 90 degree anymore. It's not angle, but pi over 2. Third time, find the sine. To find the sine, we use the old trick. We know the sine for the 3 things, and therefore the 6 things. For sine, for cosine, and for tangent. If you don't memorize this, that's fine. Okay, just do it really quickly. What's the definition of sine? It's y. Therefore, where y is positive, which means the top 2. Okay, these are where the y are positive, which is your sine is positive. This one is for x by definition, so that's where to the right it's positive, to the left it's negative. And this is going to be y over x. That means if both are positive, this one is positive. Both are negative, this one is positive. And if one is positive, one is negative, if you just divide them, you got negative. That's how we got it. So we have this. We've done this before, so very quick examples. What is cosine 7 pi over 4? Okay, you start from here, you go all the way to here, that's pi. That's 3 pi over 2. For 7 pi over 4, you need to go another pi over 4. Therefore, that is the terminal side, a terminal point. Then, your reference angle, T bar equals 2 pi minus 7 pi over 4, which is 8 pi over 4 minus 7 pi over 4, which give you pi over 4. Therefore, I should go with pi over 4. Which is square root of 2 over 2. Plus or minus, and I need to fix the sign. Now, which quadrant is this one in? Quadrant 4. What are you looking for? You're looking for cosine. Therefore, the x value for this one is going to be positive. That's how I figure out this. Okay. What about sine 7 pi? Okay, keep going. 2 pi, 4 pi, 6 pi, 7 pi. Okay, what's the coordinate? -1, 0. What is your sign? Your sign is going to be this. Therefore, 0. Okay, tangent 7 pi over 2. Pi over 2, if you think about it, it's going to be 3 pi, which is 6 pi over 2 plus another pi over 2. So first, let's go pi, 2 pi, 3 pi, and another pi over 2. This is where it is. What's the tangent here? That's going to be y over x, where the point is given by 0 and -1. Y over x, -1 over 0, undefined. Or if you memorize it, this actually belongs to 2 pi plus n pi, where n equals 3. Therefore, it's not in the domain. But either way, this is undefined. Okay, so same as before. We can do this. We also have the trig identities. The same as what we had before for triangles. The first big type, reciprocal. Which we already used, actually. By definition, we know this is true. The second part will be the Pythagorean's identities. Tangent square t plus 1. Again, be very, very, very familiar with the first two. You will see it a lot. And once you're okay with the second one, the third one is probably similar. But we will very rarely see it. Okay, with all that in mind, we can do the same thing we had before. You know one trick, you find all the others. So I will just go over one example. Let's say we already know sine t equals 1/3. Okay. Moreover, we know t is in quadrant 2. Find all the trig values of t. Somehow, sine t is 1/3. T is roughly here. Okay. Now, what do? You use the trig identities to do all this. But remember, this time you cannot draw the right triangle because it's not an angle anymore. So what you can do is you can just focus on sine t equals 1/3. number 1, cosecant t equals 3. Okay, number 2, you want to find the tangent and the secant, and then flip all of tangent and cosine, then flip all of them. Now, tangent is going to be sine over cosine. Therefore, you already know sine. If you could find cosine, you can find tangent. The key is to try to find cosine from sine. That is where we have the trig identity. Let's just try to see. Cosine squared t equals 1 minus sine squared t, which is 1 minus 1 over 3 squared, which is 8 over 9. Therefore, cosine t equals plus or minus 8 over 9. Now you can see why we need the information that sine is in quadrant 2, because sine can also be in quadrant 1 and still have positive 1/3. So you don't know which one to take, but for now, because you're doing cosine, now you know which one to take. Negative, because of quadrant 2. Okay, once you have that, of course, secant. Finally, tangent. And cotangent over 1, which we don't have to write down. So we have this, we have this. We're missing one more. Secant, cosecant, secant here. Through the whole process, we never touched anything with right triangle. All we need is we need to memorize the identity, trig identity, which we know originally was coming from the right triangle, but now we have extended for all real numbers. All right. So finally, probably the only thing new that we have never seen before is about the odd and even function property. Because now we're talking about a function of trigonometry, we are going to talk about domain, range, graph, okay, vertical asymptote, horizontal asymptote, and everything we know about graph. And one important property for graph is it odd or is it even? Try to recall what we mean by odd and even. Even function is a function that satisfies if you put it in a negative number, you got the same number. Okay, some example can be y equals x squared. You plug in -1, you plug in 1, you got the same number. They are special because that means if you go equal distance from here to here, you should have the same number. If you draw all of them, you should have a graph. You should have a graph that is symmetric with respect to the y-axis. So it's like a mirror. It's a very special type of functions. That means if you only know half the graph on the right, you can draw the half the graph on the left. If the right look like this, then the left look like this, which is very convenient. Okay. Now the second thing is the even function. Oh, the odd function, which satisfies f negative x equals negative fx. Example is y equals x cubed. Check the graph. What this one says is if you take the negative x of some x, for example, if you take 2 and you go to -2, you wonder what happens to -2. What you have is the same function value, but in a negative sense. If you have it to be here, then you have this. They are exactly the same length. It's just a flipped direction. From here, you can see the odd function is symmetric. With respect to the origin. This is what we call origin. Or you can say, if you know this part, you just take this one and rotate it for 100 degrees, you got this part. Okay, these are two very special type of properties of functions. Now we wonder what happens to sine, cosine, and tangent, and secant, and so on. Now number one, of course, let's try to see sine t. Now all you need to know is you just need to check sine negative t and see what that thing equals. We can do this by doing the graph. Just draw some random t. Where is negative t? You go equal distance, then you can see these two share the same length here. These two share the same length here. So they have the same sine and cosine, except one has a positive sign and the other one has a negative sign. So settled. They have the same length because sine t is nothing but y, right? They have the same length. But one is positive, one is negative. Therefore, we have this property. Therefore, this one is odd. Similarly for cosine t and cosine negative t. What's going on here? Well, this is t, this is negative t. You can see the cosine t for both t and the negative t is going to be the green line I just wrote down. No matter you're in quadrant 1 or quadrant 3, okay, it's the same x, or equally, this is the sign for cosine. So no matter you have positive t or negative t, you are both positive. Therefore, they are the same with a positive sign. Therefore, cosine is even. Using the same argument, I will challenge you to prove tangent t is, think about it, and the answer is going to be odd. Okay, so we have odd function, we have even function. The odd ones will be cosine, and therefore secant, because if your cosine value does not change, your secant does not change. Everything else will be odd. Oh, what I didn't do. This will be even. Everything else will be odd. That also means later when we do the graph, if we draw the graph of sine, whatever you have from here, this one should be flipped. And for cosine, whatever you have here, this one should be copied on the other side. But that's for later.